All right, welcome to Tollefson Physics. So what we're going to do now is we're going to take a situation where we have a block that's moving at a certain speed and it encounters a surface with friction. And so how can we use this idea of momentum and impulse to figure out what's going on? All right, so here's what I set up. We have a 10 kilogram block that is already moving at 10 meters per second when it hits this rough surface. All right, so we got this rough surface with a coefficient of friction of 0.2. So I would recommend drawing a force diagram for this. And the reason for that is I need to figure out what the force of friction is. And I need to think about what's going on. Now, since it's on level surface, I got a normal force and a gravitational force that's the same. I have a force of friction. The force of friction is mu times Fn, right? The maximum force of friction. And Fn equals Fg, so in this case, it's going to equal mu mg. Why'd I do all that? Because, so I could use Newton's second law to figure this out, right? I could use Newton's second law to figure out what? To figure out how long this is going to take to stop, right? So let's figure out how long this takes to stop. So I could use Newton's second law, figure out the acceleration, then use the kinematics equation to figure that out. But in this case, I'm going to use momentum. So remember, momentum is going to be the sum of the momentum prior to what happens plus the impulse equals the sum of the momentum afterwards. So what I'm trying to do is I'm trying to figure out, okay, what is the a better question to ask is what is the time? I could apply that to distance as well, but let's answer the question of what is the time involved first, because that comes right out of this equation. So what's my initial momentum, right? My initial momentum is going to be 10 meters per second times the mass. So m times v is that. What is my force that's being applied here? Well, it's this force due to friction, which I can calculate here. So let's go ahead and calculate that. So that's 0.2, the mass is 10 kilograms, and the acceleration due to Earth's gravity is 10 meters per second squared. And so my force of friction equals 100 times 0.2, so that's 20 newtons. So now let's think about this. That force of friction is in the opposite direction of my velocity. So yeah, I need a coordinate system. So my coordinate system, I'm going to have velocity as the plus direction, which means I have to represent the force with a negative sign because it's in the opposite direction it's moving, and it's important in this case. I want to figure out the time, and then what's my final momentum? Well, if it stops, it's 0. All right, so this right here becomes 100 kilograms meters divided by seconds. So that's a unit of momentum. And this will equal, so let's put this on the other side, 20 newtons times the time. So I divide both sides. So 100 kilogram meters divided by seconds divided by 20. And what's a newton? It's a kilogram meter per second squared. So what do I end up with? I do in fact end up with, 5 seconds. So it takes 5 seconds for this to slow down. Now, if I wanted to, if I want to know the distance, well, yeah, then I got to pull out one of my kinematic equations. So just to demonstrate that we can do it, we know the time, we don't know the acceleration. So how would I approach this? Actually, the way that I would approach it, I wouldn't even do an equation. I would just think about a velocity time graph. Graphs are great when it's a quick and easy thing. So what's the initial speed? It's 10 meters per second. What's the final time? It's 5 seconds. What's the distance? It's that area. So in this particular case, the area is 1/2 base times height, which would be 5 seconds times 10 meters per second. Half of 10 is 5 times 5. So the change in position would be 25 meters. You could use some equations of kinematics to figure that out, but like in this particular case, just a simple velocity time graph and not memorizing any formulas actually works quite well. All right, so we can apply this change in momentum to things that add momentum to the system, but also for things that remove momentum from the system.
All right, the best way to learn physics is to do physics. So here's the problem that we did in the video. You give it another try without looking back, hit pause, and then unpause when you're ready to see the solution. All right, so here's the solution. You can always go back to the video to see how we did this. Ultimate solution was 5 seconds. So now it's your turn to try. So here's a different situation where now we have a 1,000 kilogram car moving at 30 meters per second and it hits the brakes. And so the coefficient of friction between the tires and the road is 0.75. So how long does it take to stop? Pause the video now to do your solution, unpause to see the solution. All right, ultimately, you need to calculate the force of friction as shown here, and the time it takes for the car to skid to a stop turns out to be 4 seconds. All right, so keep practicing, and we'll see you next time.